Hello, I'm Professor Matthew Cobb of the University of Manchester, and in this lecture I'm going to be talking to you about our most mysterious sense, the sense that scientists understand the least about, and yet which is incredibly important to all of us, our sense of smell. And I'm not only going to be talking about us, I'll also be talking about maggots and Neanderthals, extinct humans. So there's all sorts of noses that animals use to detect smells. So here are a set of them. Let's see how many you can get. I guess these days a lot of students know about the one on the top left. That's the star-nosed mole, if you didn't know. The top right, fairly obvious, it's a bat. Bottom right, elephant. It starts to get a bit trickier, eh? Right, what's the top one in the middle? Well, that's an eel. And yes, fish have a sense of smell, because smell is just detecting odours, detecting molecules in the medium. And although we think about it in the air, you smell underwater as well, or some animals can. Okay, what about the others? Well, bottom in the middle is clearly a human, that's you. And then it gets a bit trickier. The two in the middle, well, one's a cat and one's a dog. That's dead easy. Right, and now we've got the last 3, 4. The bottom left one, I'm not going to tell you, you'll see later on. The one that looks like a fern, that's a moth, and it's a male moth. We'll see why that's significant in a minute. And then the last two are two other insect antennae. The bottom one is from a beetle called a cockchafer, and again that's a male. And then the other one is from an ant. So lots of ways of detecting smells, lots of organs that we have, different animal species have. And our sense of smell is in fact the oldest sense in the world. So organisms evolved the ability to detect chemical gradients and move up them long before they could detect light, millions and billions of years ago. Bacteria can smell. Now, why do we smell? What functions does the sense of smell have? Well, the kind of obvious one is to be able to find food, but it's also linked with memory, and that's one of the reasons why it's so interesting. So for me, the smell of Vimto, and if you don't know what Vimto is, it's a delicious beverage available in the north. The smell of Vimto, fruity kind of smell, immediately takes me back to Stockport Baths, because when I was a kid, we would go swimming and then we'd have hot Vimto and a packet of cheese and onion crisps afterwards. And Vimto still today takes me back straight away to being in the baths, the noise, the smell of the chlorine and all the rest of it. And this is very common effect, that smells can actually evoke memories, not in the ordinary way of, I don't know, remembering your phone number or your email address, but a kind of memory that is much more real. It's like you were back there. You smell something and you're back. You can remember your granny, what it was like when she was doing some cooking or something like that. And this is common not just in humans but across the animal kingdom. When we detect a smell, we do two things with it. We identify it, and then we also use that signal to tag whatever is happening around us at that particular moment. If it turns out to be significant, you can actually reactivate those memories using smell. Animals also use the sense of smell to find mates. Here we've got two beautiful crane flies. Sadly, we don't see them like this in the UK, but these are from North America. And you can immediately tell which is the male. He's the one on the right with the long antennae, and he's used those antennae to detect the substances produced by the female, the pheromones that the female produces. This enables him to detect them. We can see on this image of a male moth looking head on. If you look, you can see the eyes, and then this is the male moth's antennae. And they're much bigger than the antennae on the female, and these enable him to detect a female from miles and miles away. Now we can see this little example. I'm going to show you a video. What we've got on here are some silkworm moths. Now humans have been breeding silkworms for thousands of years, initially in China, and what you want for a silkworm is you want a caterpillar that will then pupate and we then use the silk that the caterpillar has produced to make its pupa to make silk for our clothes. So these moths have been selectively bred, and they are now very, very large indeed, as you'll see, because we're not interested in being able to fly, we're just interested in them being able to get very, very fat. So what you can see on the left, the green thing is a fan, and next to it there is a dish with a female moth underneath it. And you can see there's 5 rather portly male moths. So there's the hand lifting up the Petri dish. We can see the males immediately start to flutter. Straight away they have detected her pheromone, and now normally they'd fly, but they can't fly, they're too heavy, so they're racing to get to the female. There she is. Who's going to win? And he wins, and the next one is just too late. So in the race for life, the one on the left won. Other things you might want to be able to use your sense of smell for is the smell of home. So here we've got a honeycomb with bees living on it, and their nest, their hive, has its own particular smell which enables the bees to identify their home from other bees' nests. Also, you might want to use your sense of smell to mark your territory, and this is something we've all seen, dogs urinating, and they're very interested in the smell that other dogs have left. Surprisingly, perhaps, we don't actually know all the compounds that are involved and what exactly dogs are signaling, but it enables them to identify not only territory but also individuals. So there are chemical signals that enable other dogs to be able to identify the sex, the reproductive state, and even the identity of the dog that has urinated in one particular place. Smell can also give you a sense of danger. So virtually all animals will flee from the smell of smoke, because smoke is a natural part of the environment. There are forest fires, and you need to be able to escape very quickly. If you're unlucky enough to have a fire in your home, you will wake up because of the smell of smoke. It is deeply wired into animals' brains and genomes to be able to detect smoke. And as I said, virtually all animals will flee from smoke, but there are some exceptions. There's a beetle, in particular found in Australia, which lays its eggs in charcoal. So when that beetle smells smoke, it flies towards the forest fire, and when the charcoal has cooled enough for it to be able to lay its eggs, then it can actually find a niche. So as always in the natural world, what in general looks one way, dangerous, there are going to be some species that are unable to turn it to their advantage. The final way that we need our sense of smell is in taste. Now, before COVID, people always thought this was a bit crazy, but I think we all begin to understand now that there's a link between smell, which is affected by COVID, and taste. And often people who got COVID said, I couldn't taste anything. I'm going to show you in a minute how that works by doing a little demonstration. So you need to go away and get some kind of sweet, a Skittle or a jelly bean, or if you haven't got anything like that, then anything small that you can easily put into your mouth which is strong tasting. And I'll show you exactly how it works.